Hello everyone, I am Dr. Fawzul Atiq giving some series of lecture for the course Discrete Mathematics. So we are in the unit of basic principle of counting or counting principle. So in the previous lecture we have learned the product rule. So today we'll start with the sum rule. What is that? If a task can be done either in one of n1 ways or in one of n2 ways, where none of the set of n1 ways is the same as any of the set of n2 ways, then there are n1 plus n2 ways to do the task, which is actually very easy to understand. So suppose you want to move from the place A to B. You want to move from the place A to the place B. Now, suppose there are n1 ways to uh, move from A to B. Suppose you have n1 ways path you have, and in another way you have n2 ways, n2 number of paths to go from A to B. Then none of them are overlapping. So there are how many total number of ways you have? n1 plus n2 number of ways. So this is basically the sum. So if a task can be done either in one of n1 ways or in one of n2 ways, where none of the set of n1 ways is the same as the none of the set of n2 ways, then there are n1 plus n2 number of ways to do the task. Right? So this is called the sum rule. I hope you understand easily. Okay. Let us do an example. Suppose that either a member of a Suppose that either a member of the mathematics faculty or a student who is a mathematics minor is chosen as a representative to a university committee. Then how many different choices are there for this representative if there are 37 members of the mathematics faculty and 83 members of the uh, mathematics minor, and no one is both as a faculty member and a student? So, but what you have to do? Suppose that either a member of the mathematics faculty or a student of mathematics minor will be chosen as a representative to a university committee. So, one person you have to choose, right? That one person can be a mathematics faculty, that one person can be a mathematics minor student, right? And there are 37 mathematics faculty members you have, 83 mathematics minor student you have. So, to how many ways you can choose? So, you have 37 faculty member you have. So if you want to make that person is a faculty member, so how many choices you have? 37 choice. If you want to think that that person is that member is a minor mathematics minor student, how many choices you have? 83 choices. So none of them are like same. Like one student should not be a faculty member, right? They are different. So altogether, how many total number of choices you have? 37 plus 83 number is equal to 120 number of choices you have to select the representative for the university committee, right? Which is very easy problem. I hope you understand easily. Okay. Yeah, so that's what we have discussed. 37 plus 83 equal to 120 possible ways to pick this representative. Now, I hope you know what do you mean by alphanumeric number. Alphanumeric numbers are alphabet and the numerics, right? Alphabet means it is A, B, C, D up to Z. Now alphabets can be, you can distinguish also, right? Capital letter and small letters are different. Somewhere in some problem you may see that okay they are distinguished, some problem you may see they are not distinguished. And numerics means they are the digits. What are the all numerics you have? 0, 1 to up to 8. So alphanumeric characters are, it is 0, 1, 2 up to 9, all the numerics, all the digits, and the alphabets A, B up to Z. And here A, B, I have taken the capital letter. You may have the small letter also if you distinguish them. So depending on your problem, we will decide how many alphanumeric character we have. Okay. Now let us solve an example. In a version of the computer language, the name of a variable is a string of one or two alphanumeric characters. Right? Name of a variable is a string of one or two alphanumeric characters, where uppercase and lowercase letters are not distinguished. That means uppercase and lowercase letters are same. So they don't distinguish. So they will be treated as same. Now, moreover, a variable name must begin with a letter and must be different from the 5 string of 2 characters that are reserved for programming use. So, moreover, a variable name must begin with a letter. So, whatever variable name you'll have, that should start with a letter, whether it is 1 digit, 1 character long, or like 1 alphanumeric character or 2 alphanumeric character long, and must be different from 5 strings of 2 characters that will be reserved for programming use, right? So there are few things you have. So the question is, how many different variable names are there? Now, how you can understand this problem, how you can frame the problem. So basically, you have to find how many different variable names you have. So how the variable names are? They are either 1 alphanumeric character or 2 alphanumeric character. So it is either 1 alphanumeric character or 2 alphanumeric character. It is like that. Now, what we will do? So this alphanumeric characters, if it is 1 alphanumeric character, so assume that there are V1 number of alphanumeric characters names are there, and there are V2 number of 2 alphanumeric characters names are there, variable names. So altogether, how many then? By sum rule, because they are not same. So by sum rule, there are V1 plus V2 number of variable names will be there, right? Now, to assign the name, there are some restrictions. A variable name must begin with a letter, whether it is 1 character long or 2 character, right? So variable names are must be an alphabet and a letter, and then upper and lower case are not distinguished. So they are same. You can be treated as same, and must be different from 5 strings. So now, if the variable name starts with an alphabet or a letter, so how many single alphanumeric characters alphabet you have of one, like 1 alphanumeric characters variable name you'll have. So if it starts with a, so they can be either A, B, C, any number, right? So for V1, how many choices you have? It is 26 number of choices, because they are one alphanumeric characters variable name, and it starts with an alphabet, so it should be alphabet. So how many for V1? How many choices you have? You have 26 number of single alphanumeric characters variable. Now think about V2. V2 is what? V2 is the 2 alphanumeric characters variable names, where the first digit is an alphabet. So V2 have 2 positions. First one is an alphabet, and the second one is an any alphanumeric number, right? So for first position, how many choices you have? You have 26 choices. And for the second case, second position, it can be any alphanumeric character. But how many total number of alphanumeric characters you have? How many total number of alphanumeric characters you have? These are the number. They are total 36 number, because capital letter and small letters are, you can treat it as same. So there are 10 digits and 26 alphabet. So 36 number of alphanumeric characters you have. So that will be filled in the second position. So in the second position, you have 36 choices, right? And one more thing. So V2, so 2 alphanumeric characters variable names are how many total then? It is 26 into 36 number by product rule. And then the last part, then must be different from the 5 strings of 2 characters. So 5 strings are reserved. So then V2 is what? It is 26 into 36. So total this many 2 character long variable names you have, minus 5s are reserved. So V2 is 26 into 36 minus 5. Right? So if you calculate, you will get this number is 931. And V1 you already have, it is 26. So altogether, by sum rule, how many different variable name you'll have? It is V1 plus V2, which is equal to 26 plus 931, which is equal to 957. Our problem is done. So there are this many variable name we'll have. I hope you understand that. So the complete answer is given here. And as we discussed, there are V1 plus V2 is equal to 26 plus 931. So 957 variable names will be there. Clear? Let us have another problem. Each user on a computer system has a password, which is 6 to 8 character long, where each character is an uppercase letter or a digit. Each password must contain at least one digit. Then how many possible passwords are there? Right? So how the passwords are made? It's are either 6 character long or 7 character long or 8 character longs. Right? And where each character is an uppercase letter or a digit. So basically they are alphanumeric number, but you only have to take the uppercase letter. One more thing, each password must contain at least one digit. That part also need to be taken care. So if then how many different password you can create? So you assume that suppose P6 is the number of password of 6 character long. P7 are the number of characters of 7 character long, and P8 are the number of password of 8 character long. Correct? So suppose these are the number. So P6, P7 and P8. So 6 character, 7 character and 8 character long passwords. So how many total number? It will be P6 plus P7 plus P8 by sum rule, because none of them are overlapping, none of them are having any common password. So 6 character is different from 7 character long, or it is different from 8 character long. Now how to count the P6? That means how many 6 character long password will be there? Let us count that. So each password P6 you have 6 position, right? You have 6 position, and they are either uppercase letter or a digit. So they are either a uppercase letter or a digit. So 6 position you have. So for the first position, how many possibilities you have? How many ways you can do? Uppercase letter or digit, that means total how many? 36. Similarly for the second also 36. 36. If I only taken care of this, it is 36, 36. This many password you have. But there is another point. Each password must contain at least one digit. So each password must contain at least one digit. So how to incorporate this line? So you think about the case where none of the password contains any digit, right? So that means how many passwords you can create where no digits will be there. That means what? It should be only uppercase letter. How many such cases are there? So if you subtract that many number from this big number, you can get that number, original number. Each password must have at least one digit, correct? So if you only have the this like no digit number, only alphabet, so then also you have 6 choices. So it is 26. Only alphabet means 26 alphabet you have. So 26, 26 like that you have 26 power 6. So by product rule, it is 36 power 6 number of uppercase and digits, 6 character long password we get. But if we remove that only alphabet cases, so they are 26 power 6 number of cases. So each password must contain at least one digit means, so P6 should be, your P6 will become 36 power 6 minus 26 power 6. So what we basically did, because I need at least one digit should be there in each password, so I removed the case where no digits are there. So how many such cases are possible? 26 power 6. So I just remove it. So I got this many 6 character long password are there. If you have understood this, now what is P7 then? We have easily understood, because now P7 I'm going to count that how many 7 character long passwords are there. So again, the same thing we'll do, 36 power 7 minus 26 power 7. And similarly, P8 is equal to 36 power 8 minus 26 power 8. And then by sum rule, how many total number of password you have? It is P6 plus P7 plus P8 number of password. And if you add all of them, If you add all of them, you may use the calculator. The number will be 2,684,483 and then 063, 360. This many different password you can create if you take this method. Right? So understand that how the strong password will be. This many different things are there. So it will be very easy to predict, very difficult to predict this password. Right? Now you should also realize that so whenever you are going to create a password in the system, it asks several things. Na? That at least one alphabet should be there, at least one special character will be there, at least 8 digits should be the minimum character long. So understand or try to realize the situation, how strong these passwords are. Right? So people cannot predict it. Clear? So whatever I have discussed, so this is the one. So your P6 will be this number, P7 is this, and P8 is this, and all total there are P6 plus P7 plus P8 number of passwords you can have. I hope you understand. Okay, the next problem. Now, next we have the subtraction rule. So what is that? If a task can be done in either n1 ways or n2 ways, then the number of ways to do the task is n1 plus n2 minus the number of ways to do the task that are common to the two different ways. Right? So here it is basically the sum rule type only. It is basically the sum rule only. But here this point is missing, that there should not have any common thing. Suppose A to B you want to move. You have move and you have n1 number of choices here, and you have n2 number of choices from here. So some of them are common. So that part you are counting twice. Right? So then it is how many total number of ways you can do? It is n1 plus n2 minus the number of ways to do the task which are common in two different ways. Right? So number of ways to do the task in common ways. This common part was missing, is missing in this case. So you have to subtract it. Right? In set theory, you must have seen this kind of thing. Right? In set theory, we have seen this. So the subtraction rule is also known as principle of inclusion-exclusion, especially when it used to count the number of elements in the union of two sets. Right? So union of two sets, suppose I have this thing, the two sets I have. So this is the intersection part, some elements are there. So this is the set A1 and this is the set A2. So how you can count the A1 union A2, A1 union A2. So A1 union A2, once you do, so it is if you count all element in A1 plus all element in A2, so this portion you are counting twice, right? So one time you have to remove. So this minus A1 intersection A2. So this is the subtraction rule also. So the n1 ways to do the first task plus n2 ways to do the second task. So n1 plus n2 minus the common ways to do this task. I hope this is clear. So this subtraction rule is also known as principle of inclusion-exclusion. Now let us do some problem. Again, a very, very interesting problem. How many bit string of length 8 either start with 1 bit or end with 2 bits? So length 8 bit string you have to find out. So there are 8 characters you have. Each of them are bit string. That bit, that means either 0 and 1. And then you have something. So suppose each bit strings are looking like this. It's an 8 character long. Each of them are bit. That means each position will have two choices, 0 and 1, 0 and 1, like that. Now, there is some special condition. Is either start with 1 bit. So you have to count. So how many bit strings are there of length 8 which starts with 1 bit? That means for the first position you have only one choice, which is 1. And all others are two choices you have. So they can be 0 and 1, they can be 0 and 1, 0 and 1. Right? So how many bit string you have which starts with 1 bit? It is 1 into 2 into 2 into 2 into like this. So it is 2 to the power 7. Next, or end with 2 bits or end with 2 bits. So how many length 8-bit strings you have which are ends with the bits 0 and 0? So the last two digits are 0 and 0. So then for this, so it should be either 0 and 0. No other choice. So these two position you have only one choice, and all other position you have two choice. Then how many bit string you have which are end with the bits 0 0? By product rule it is 2 to the power 6. Clear? Now then how many total number of bit string you have which are either starts with 1 bit or ends with 0 0 bit? It is 2 to the power 7 plus 2 to the power 6. But there is a catch, because these things you are considering in some places where starts with 1, here these 0 0 cases are also included, na? Or in this case whenever you are counting, that bit string where it starts with 1 is also included. So that the string which starts with 1 and end with 0 0, you are counting twice. That part should be removed. So starts with 1, ends with 0 0. These parts are you are counting in both the places, here and here both. That part it's a common thing. It needs to be removed, right? So how many such bit strings you have starts with 1 and end with 0 0? So you have one choice here, you have one choice here, you have one choice here, and all other places you have two choice. So altogether there are 2 to the power 5 number of choices. So what is the final answer then? So the final answer will be 2 to the power 7 plus 2 to the power 6 minus 2 to the power 5 number of bit strings of length 8 are there, which are either starts with 1 bit or ends with 2 bits. I hope it is clear. Easy. So we have applied the subtraction rule here. Clear? So this is the final answer as we discussed. Starts with 1 bit, it is this. End with 0 0 bit, it is this. And which are common, 1 bit starts with 1 bit and end with 0 0 bit, it is 2 to the power 5. So by principle of inclusion exclusion or by the subtraction rule, you have 2 to the power 7 plus 2 to the power 6 minus 2 to the power 5 is equal to 160 ways to bit string you have. Next, we have one more example. Look at this problem. A computer company receives 350 applications from computer graduates for a job planning a line of new web series. A computer company receives 350 applications from computer graduates for a job planning a line of new web series. Now suppose that 222 of these applications measured in computer science, 147 applicants are measured in business, and 51 measured both in computer science and in business. Then how many of these applicants measured neither in computer science nor in business? See, your total number of applications is what? 350. Then here 2-3 cases are there. Some of them are measured in computer science, some of them who are measured in business, and some of them who are measured in both in computer science and in business, and some will be there which who are neither measured in computer science nor in business. Right? So there are 4 such cases. So how to find that? So total number of applications is 350. Right? So suppose A1 is the number of applicants which are A1 is the set which contain the all the computer science major, right? A1 is the set contains all the computer science major, and A2 is the set which contains the all the applicants who are business measured in business, right? Measured in business. Then according to what is given, it is given that cardinality of the set A1 is 220 who are measured in computer science. What is A2? Cardinality of A2, that how many are there measured in business? It is 147. And what is given that 51s are measured in both in computer science and in business. So A1 intersection A2. This one is equal to 51. These things are given. Now what you can find, so now you check that how many applicants are there who are either measured in business or measured in computer science. How to do that? So there it is intersection, but either or if we do, it is A1 union A2, right? So this many applicants are there who are either measured in business or measured in computer science. But by principle of inclusion exclusion, what is the formula for A1 union A2 cardinality? It is cardinality of A1 plus cardinality of A2 minus cardinality of A1 intersection A2. So what is this value? It is 220 plus 147 minus 51. So if you calculate, you will get this value is 316. So this many applicants are there who are either majored in computer science or majored in business. But there are 350 applicants are there which are total number. So then how many of them who are neither majored in computer science nor in business? So the answer is 350 minus 316 is equal to 34 applicants are there who are neither majored in computer science nor in business. I hope you understand. So we have applied the principle of inclusion exclusion here or the subtraction rule and we have solved the problem, right? So this is the complete answer of it as we discussed. So this is the like the formal answer. So all the content I have taken from this book only. I hope these videos are helpful for you. You are really enjoying this video. If such, if this is the case, if you like it, kindly like the videos, promote it, you share with your friends, and please subscribe this channel because this channel have another series of videos which are probability and statistics course, which will be again helpful for you. And if you subscribe, I'll get a lot of motivation to make this video. Thank you very much. We'll come up with a new video in the next lecture. Thank you. Bye-bye.